Today's problem from sequence of real number, and the problem says that if alpha n equal to 1 to infinity, this is a symbol of sequence, is a sequence of real numbers and alpha be a non-zero real number such that limit n tends to infinity, alpha 1 plus alpha 2 plus alpha n, this is equal to alpha. That is the limit of the sum of first member of this sequence is equal to alpha. It is given. Then we have to find the value of limit n tends to infinity alpha n. Okay, and 4 options are given. Here we use the definition of convergent limit. What is the definition of convergent limit? We know that if limit n tends to infinity an, this is equal to L. That is, if the sequence converges to L, then from the definition it is said that for every epsilon greater than 0, however it can be small, we take, there exists a natural number k such that mod of an minus L less than epsilon for all n greater or equal to k. This is the definition of sequence of real number which is convergent. Okay, and we also use a popular formula. This is triangle inequality. This is given by mod of a minus b less equal to a minus c plus mod of c minus b. It is very simple property of inequality. Now if we write the sum of first n member of this sequence is Sn, then we can write that limit n tends to infinity Sn, this is equal to alpha, and here Sn is also a sequence of real number, and also we know that this is the sequence of nth partial sum, right? And in this case, for epsilon greater than 0, there exists k belongs to capital N. Using this definition, we write that mod of Sn minus alpha less than epsilon by 2 for all n greater or equal to k. This is the definition of convergent sequence. And since this is hold, so this relation also hold if we write n plus 1 in place of n. Why it is hold for n plus 1? Because in this case n plus 1 is also greater or equal to k. Since it is n greater or equal to k, so n plus 1 is also greater or equal to k. So we can write the relation n plus 1 minus alpha less than epsilon by 2. Okay. Now using this inequality, we write that Sn plus 1 minus Sn. Clearly, this is equal to less equal to mod of Sn plus 1 minus alpha plus mod of alpha minus Sn. Okay, and this is less equal to Sn plus 1 minus alpha plus mod of Sn minus alpha. And we put here, this is epsilon by 2, and also put here epsilon by 2 for all n greater or equal to k, right? So we get the result, this is epsilon for all n greater or equal to k, and this relation is nothing but this is Sn plus 1, so this is the sum of alpha 1 to alpha n plus alpha n plus 1, and minus Sn, this means alpha 1 to alpha n, and we subtract these two results, getting the result as alpha n plus 1. Okay, so we write that mod of alpha n plus 1 less than epsilon for all n greater or equal to k, and we write this relation alternately as alpha n plus 1 minus 0 less than epsilon for all n greater or equal to k. And obviously this is the definition of the convergent sequence. So we write here limit n tends to infinity alpha n plus 1, this is equal to 0. Okay, and since n tends to infinity, so there is no distinction between limit n tends to infinity alpha n, this is equal to 0, and this limit. Okay, so we say that the value of L, this is equal to 0, and obviously the answer is option number 4, this is 0. Very important type problem, but we solve this problem using just only definition of convergent sequence. Thank you for watching.